Due to technical difficulties, a portion of this presentation was not recorded. We are joining the program already in progress.
The results here are mostly from an out-of-the-box configuration and with the release version of Vista, the one they call RTM. And full details of this project are available in a paper, which is available on the Semantic website. It's also on the conference CD. Okay, we also looked at the security implications of Teredo. Teredo is a genus of shipworm, and although shipworms are called worms, they're not really worms, they're really mollusks. And there are some significant security concerns if you have a wooden boat or a piling and so forth. That's because they could bore holes in the wood. So you need to watch out for that. Okay, the other Teredo that the project was actually on was a platform-independent analysis of the security applications of Teredo. This is an IPv6 transition mechanism for tunnels that tunnel through NAT. It is enabled by default in Vista. And full details of this project are in a paper which is on the conference CD and also on the Semantic website. Okay, I'm going to organize this talk as follows. There's first I'll talk about Vista's new network stack and firewall. You go into some of layer 3 and 4 results. Then specifically, I'll go into the IP and TCP reassembly behavior. Then I'll go into the Teredo protocol, the background on it and how it works. Go into some of the security applications of Teredo. If time permits, I'll talk about LLTD. Then I'll wrap up. Some of the differences in Vista's networking that I'll discuss today is that the stack is a rewrite. IPv6 is enabled and preferred by default. There's IPv6 transition mechanisms present. There's more tunneling mechanisms than in XP. There's the new Windows firewall. IP and TCP fragment reassembly is different. There's other different stack behaviors and other new protocols and exposures. When you have these new protocols and behaviors, these have implications for security devices, and they should also influence enterprise security policies and controls. I'd like to say that Microsoft loves IPv6. They've had this document titled Objectives for IPv6 up on the Microsoft website for a few years, and that lays out why they love IPv6 so much. And the main thing is that the global addresses and the absence of NAT means that peer-to-peer and games are easier to set up. The TCP/IP stack was rewritten in Vista from the ground up. This is at least partly to support IPv6 fully. And IPv4 and IPv6 are fully integrated in this stack. And as mentioned, IPv6 is enabled and preferred by default. So IPv6 is here. IPv6 has a number of positive and negative security implications. The list I have here, actually, all these were developed a couple years ago, even before Vista at all. And so these apply in general to IPv6 implementations and installations, and hence they apply to Vista environments. One of those security implications is that the possible attack surface is roughly doubled. That's because you have the IPv4 avenue of attack and the IPv6 avenue of attack. So it's twice as much as you need to protect. And I wouldn't say twice as much vulnerability possible, but definitely increased. Another thing is that the network security controls may not be ready for IPv6, and even if they are, they may not be configured properly, just because it's so new, and in fact there's less best practice available. You may not have turned on the firewall for IPv6 as well as IPv4 for a certain role. Another thing is that there's new, less tested code that will be present in stacks and in applications. IPsec is a standard part of IPv6, so you have the encryption and authentication available, although there's challenges to actually using it. Blindly scanning of internet addresses is generally infeasible, though there is other methods of host discovery. And tunneling raises security concerns. Okay, this rewritten stack means there's lots of opportunities for new vulnerabilities. Stacks are complex entities. They take typically many years to mature. There's thousands upon thousands of lines of code. So there's just lots of possibilities for things to go wrong. And Microsoft did do extensive security design and testing on the stack, and that has certainly limited a number of possible vulnerabilities. And in fact, in a beta 2 build, we did find three historic well-known stack attacks, like the land attack, and 3 crashes just from simple IPv4 fuzzing. So you make your own judgments on that. This is in beta 2. There's a number of new protocols in Vista. I'm not going to try to read the full list here. So there's new protocols, and there's a number of ones that are also re-implemented. Okay, and because Microsoft loves IPv6 so much, they want to promote more clients to be able to use IPv6. They've implemented a number of transition mechanisms, including ISATAP, which is IPv6 tunneled directly on top of IPv4, protocol 41, and Teredo, which is IPv6 tunneled on top of UDP on top of IPv4. These mechanisms can allow hosts to use IPv6 even if something on the path to your peer, IPv6 peer, doesn't support IPv6. So they do that by tunneling. Just as a brief background, the IPv6 header consists of a simple base header followed by 0 or more extension headers. The defined extension headers include hop by hop, destination options, authentication header, ESP, fragment for fragmentation, routing for source routing, and a mobile IPv6. And all but that last one are supported by Vista and any IPv6 implementation. Now I'll talk about what we found about this new firewall in Vista, just based on a kind of a limited study that we did. The firewall is enabled by default, and it does default deny, and there's fairly limited exceptions initially. In Vista, there's this concept of a profile that each network is in, and the 3 built-in network profiles: public, private, and domain. And what this profile is used for, among other things, is that it selects what rule set is in effect in the Windows firewall. Now, Ollie and I did find a vulnerability in Windows Vista in the firewall specifically, and we reported this to Microsoft. Sort of by design, what was supposed to happen is that inbound traffic over Teredo was only allowed when there's a special flag set, edge traversal, in an active firewall exception. And since there isn't any exceptions like that initially, nothing was supposed to be allowed inbound over Teredo. That's not quite how it got implemented, though. Somehow in Mr. Testing as well, is that the firewall allowed over Teredo anything that would be allowed from the local link. Oops. The exposure depends on the current firewall rule state, but sort of for out of the box and for TCP, it meant port 53 or 57 was available from the internet over Teredo. This was fixed in Microsoft's MS0738, and we documented this in the Semantic Security Advisory as well. You can read the advisory for more details on this. We also wanted to find out how certain GUI actions in Vista affected the Windows firewall and the active sockets. For example, what happens if you turn on file sharing, turn it back off? What we observed is that certain features, when they're turned on, they create exceptions in the firewall. After consent prompts. But then you turn off that feature. Those exceptions don't always go away. These leftover exceptions even persist across a reboot. And thus, a legacy of firewall exceptions builds up until it's manually disabled. You have to go manually check them off. Here, this is just lists some of the things we found for the sticky rules. Actually, I think this lists all the ones we found in our limited testing. For example, you turn on media sharing, turn it back off. Well, the Windows Media Player group is still the exceptions for those is still there for the private and domain profile. So these sticky rules increase a host exposure, at least in theory, at least. Because it's lowering the defense. But of course, you actually need an active listener, to really connect in. And generally, the sockets did closely match the GUI state. We did find one small exception, though, is that you turn on Windows Meeting Space and then turn it back off. We did find that port 5722 was still available for an extra few minutes, just a couple minutes. So it isn't that great of exposure, but it's a little bit interesting nevertheless. Okay, now going to some of the layer 3 and 4 results. One of the first things you might do is when you have this new network stack that you're presented with is to do scans and protocol enumerations, and that's what we did for Vista. Looking at doing an IPv6 protocol scan, which is actually called next header, is the name of the field in IPv6. We found that most of the protocols would produce a parameter call message about an unknown protocol, which meant we can map which protocols appeared to be serviced. However, with IPv4, when we did the protocol scan with Vista, that with the firewall on, we didn't get any protocol unreachable messages. So just for the sake of seeing what's intrinsically available, we tested with the firewall off as well. These first results I list here, TCP, UDP, IGMP, those are pretty much what you expect. And we did find that ESP and AH, which are for IPsec, are available in both IPv6 and IPv4. Now in IPv6, these are extension headers, and there's 4 other extension headers, which I mentioned earlier, that those were present. But one surprising thing, though, is that right here, protocol 43 and 44 showed up as available over IPv4. And that's weird because those don't have any defined meaning under IPv4. For IPv6, they're fragment and routing.